what's up guys, in a month or so we're going to collect Chromebooks from all the students, and if they've got it, it's fine. If it needs repair, we'll do that. But if they have nothing, we're going to send an email home. And that gave me the idea for this project. What if you had to look up somebody and send an email to the parent? We've got data here that is exactly the same as what you would get when we get a report on students, last, first grade, ID, and then whatever else we ask for, like a locker number or where they are in third period. And in this case, it's the parent name and email. These are fake names. Don't worry about any privacy issues. But I made them realistic so that the parent and student usually have the same last name, or it could be half and half, like John Brown might have a parent whose last name is Brown hyphen something else. And then the parent email is usually based on their name, but it could have random words or numbers. So our code here, as I've tried to summarize in these comments, is going to read that data, make some kind of way to look them up, and then look them up based on IDs. So we get a student ID, we say, oh, here's that person, here's their stuff, specifically what we need for this email. Okay, we're not going to actually send an email, although in real life the school has a service to do that once we prep everything else. So the good news is 100% stuff we've done before. In the last quarter and the one before, we've done reading from a file, making a dictionary or other function to look things up. We've done attributes on some kind of object, person.name or person.grade or something like that. And we've put info into strings. In this case, you might want to put the name, like to the parents of Johnny Smith, here's the boilerplate message. Okay, so let's get started and see how far we get today. We're going to say open, and then the name of the file, which is student data. I called it txt, even though if I got this in real life, it would be XLS or CSV, just because that's easy to work with. And when I tried some of those on CodeHS, they had this weird color trying to interpret the data, and I just wanted it to be plain. So txt, and we say as f because you give it a name. Traditionally, when people name a file, they just call it f. And if you're looking at somebody's code and you see f, you know, okay, that's file. We're opening it. We're going to use that name in the very next line, so it doesn't have to last. It doesn't have to be super meaningful that we know what it means 100 lines later. And we're going to use the keyword with, because Python has a concept called context managers. If I open a file and I get an error, do I handle that? Do I close the file without causing any issues? Or even if everything works, maybe I still have to close it at the end. Well, the with, the context manager, has already built in those concepts. So all I have to do is read it and then move on, and it will be handled. Speaking of that, we could say f.read, which is a method that will just take the whole thing in one giant string. In this case, it'd be like, I don't know, 5,000 or 6,000 characters, and that's probably not what we want. So there's another one, even nicer, called readlines, to get them separated into lines. So let's just try that. Obviously, we're going to add more, but if I test it now, I get to see if this is a good start. Maybe I had a typo, maybe I forgot something. And then if I test it later, I know that it's something past this, rather than waiting until the end when I had a stupid mistake. So if I run, let's see what happens. Yeah, this is reading the file. It's getting the lines. They're not pretty, they're not meaningful, they're not organized, but we do know that we can open the file, read it, close it, get the stuff, put it in a list of strings. Cool. So what do I want to do? Well, let's take a look at the lines and see how far they are from something workable. So right away you notice this little \n at the end of each line. That's called a new line character. It's just like hitting return or enter on a keyboard, and that's what they use on the read lines to break it up. But I want to get rid of those. I don't need it, and it's going to mess up that email address. So I'm going to say l.strip for L. L is just short for line in this case. And so that's going to be one little move in the right direction, so that now I have these lines without the \n, so that it's a real clean email address. Strip takes off from the left and right anything that is not sort of content. It takes off blank spaces and tabs and new lines and maybe other invisible characters that often show up when you get data from input or you get data from a spreadsheet. Might accidentally have a space at the end or something like that, and we don't want them. So what else do we want to do? Well, we want to split it up into the chunks. So for example, at the top of the file it has these column names, just like you'd see on the first row of a spreadsheet. And that says, okay, the first thing is the last name, and the couple things later is the student ID. But right now we don't actually have these separate. We have the grade, just some characters right after some other characters. And I could do split to get those. I could say, okay, split on a comma, because the comma is the separator, or sometimes it's called the delimiter. And now if I run, hey, it'll split on commas. Now this is dangerous. I would never do this if I'm reading a real spreadsheet, and that's because there could be commas inside of the data. So for example, if I gave a survey and I let people type on one of the questions, they might use commas in their content, and then when I try to split it, I split the thing that was supposed to be one column into more than one, and now I'm completely thrown off. Now I happen to know that this does work because I generated the data and there's not going to be any commas in there. But we could also use the Python CSV reader. CSV reader is meant for this, and it more intelligently handles this kind of thing. If I wanted to test, I could say, give me the length of each list, and it would say that they're all 7. But in this case, I'm confident we can always change it later. It would be the same. It would be one line either way. So now I've got the last name, the first name, the grade, the ID as all separate things, but they're still not meaningful, right? They're all just strings. And so Python doesn't know that this is a first name. Python doesn't know that this is an email. Python doesn't know that this is a number. And so they wouldn't be very useful. For example, if I wanted to sort by grade, I might not get 9, 10, 11, 12 in order, because the computer might say, oh, 1, 0, well that's before 9 in character order, so maybe 9th grade would be last. We don't really want that, so we could tell it, hey, that's an integer, we want to use it as an integer, and so 9 is less than 10. Maybe that'll come up later. But for now, what if we wanted to make the absolute simplest possible second step here to look up? Well, we'll make a dictionary. I'm just going to call it lookup, but we can always change the name later. And so we want to make the ID the key Right now, the ID is the only thing that's guaranteed to be unique, right? So last name Meyer could be repeated. There are probably lots of others. First name Leslie could be repeated. There are probably lots of others. Grade 11, well, there's definitely lots of other grade 11s. Okay, ID, that is guaranteed to be unique. And when I generated the fake data, I made sure that they are. Okay, and then last name and first name on the parents, and then the email. None of those are guaranteed to be unique. The only thing that is the ID, and that's why we have IDs. So that's what it's going to be used for. So where is that? Well, it's 0, 1, 2, 3. We could say line 3, colon, and then it could just point to the whole line. So, hey, you got the ID? Well, here's everything else. 4 line in lines. Now, I know that's extremely vague and hard to read. If somebody pulled up this code, they would make, what the heck does that mean? Line 3? I don't know what that is. Lines? What kind of lines? So later we want to go back and add some labeling, some better names, maybe put it in a function, and then the function tells us what it does. But just as a test, let's print that. And despite the ugly look, you'll see that, okay, this ID points to the info about that person. This ID points to the info about that person. So we could start to look them up just with this. And this is only 3 lines. That's why people love Python, because 3 lines did a lot more than 3 things. It opened the file, read the string, split it into lines, stripped the edges off, split that line into parts, put it in a list of lists, closed the file, made a dictionary, and all of that was accomplished with a very small amount of typing. So let's say that I want to start looking people up, okay? I could say student ID equals input, enter ID to look up, and then I'll say if it's in there, we'll tell them. If it's not, we'll say, hey, not found, something like that, okay? If student ID is in the lookup, then we'll say student found, print, print lookup, bracket student ID, meaning that's what you get when you look it up, okay? Else we can say student not found. Now let's give that a try. I'm going to say 943961. That'll be a number we'll look up. 943961. Okay. Hey, student found, and then it gave me all the info about this student. Cool. What if I try another one? Now that one's probably not in there because I just made it up. Okay, it's not. We're testing 100. There are only 100 in that file. And with 6 digits, there are almost 1 million possibilities. So if you just put random digits, it's probably not going to find one. Yeah. So this is working. Let's do another one that works. Let's say 491887. Oh, typo. We could have some processing on the input so that if they accidentally put something after, or they accidentally put a space, we'll just get what they really meant, and that might be nice. Some forms where you enter a number only let you do numbers, and they just don't even let you put brackets and stuff. But this did find the person, and I'm going to test one more thing, which is the most common error in the world. Blanks. Whenever you get input or you're waiting on a download or whatever, the most common error is what if you just get a nothing. So we got to test that. And then finally, let's go back to one that we've already done, because sometimes you have to look up something twice and you want to make sure that it works. It didn't like delete it from the file, or it's not going to give me a different one the second time. So let's try 943.961. And hey, it did find Jeffrey McMahon just like it did the first time. Okay? Now, I'm going to stop here, even though there's a lot more to go. We're going to actually label these attributes, because right now it's just a line of stuff and nobody knows what means what. We're going to handle some errors, and we're going to use the data that we find. But I'm going to stop here because, like I said, this is doing a lot with a small amount of lines. Since this line is doing like 6 different things, it has 6 different ways that it could go wrong. Maybe you can't split it into lines, or you can't split on a comma, or you can't strip, or you can't make a list of lists, or the name is bad, or you can't close the file. There are all kinds of issues that can go wrong, so let's handle that now. If you're trying to follow along and you're getting an error, take some time and figure it out before we go into putting these into functions and giving them better names and putting the student data into some kind of object and giving those attributes names. That'll be tomorrow or the next day. Thanks.